Right, my next set of videos will help you with your Trig homework assignment. And what I'm going to go through specifically is an example that has the triangle parameters given while they're described, but you're not given a diagram, so you have to create your own. So let's talk about how the diagram works. We've got a triangle called XYZ to start. All right, and one important thing that we've got to keep in mind is that X is the 90-degree angle. Right now we're working in triangles with 90 degrees. So X is going to be that 90-degree angle. So let's draw this triangle over here and make a 90. And that's the one that we're going to call capital X. All right, so the angle is marked with a square, meaning 90 degrees. That means over on this side, the side length is always the lowercase. So there's our small x over there. The angle is always our uppercase, which is the larger one at 90 degrees. Another piece of information we're told is that angle Z is 63 degrees. Now, this will be confusing at the beginning, but it actually doesn't matter whether you put Z up here, as you choose that as your Z equals 63, or down here. Both will work, and you'll see as we go here how that happens. It's just basically meaning that the diagram doesn't necessarily have to match. It's that the sides and the angles need to match. So, I don't know, I could choose this one as my capital Z, and that's my 63 degrees, right? And that's going to be my reference angle. Because that's the angle I was given. And I will also take a look at other piece of information given. Lowercase y equals 4.2, so we're talking about a side length. So this has to be the other y angle, right? X, Y, Z. Right across from uppercase y has to go lowercase y. And of course, right across from capital Z has to go lowercase z. There we go. We were told that y was equal to 4.2, and there it is over there. Okay, so we've got our triangle set up correctly. What did we start with? Well, we had x at 90 degrees, lowercase x is right across from it. Z was 63 degrees. It didn't matter whether I put it up top or over on the bottom right. I chose up top arbitrarily. That angle is 63 degrees, and small z is down right across from it. That makes, by default, this last lower right-hand side capital Y, and directly across from it is lowercase y at 4.2. So if you always line up your angles directly across from the sides, everything should work out. Now the next question is, what do I do? What am I solving for? Okay, so we were asked to solve for the value of z. Okay, and it's lowercase z, so we're solving for a side length here. All right. The next important step is going to be labeling the diagram. So across from our 90-degree angle is always the longest side in the triangle, hypotenuse. All right, now because we chose 63 up here as our reference angle, that is going to make this lowercase z over here our opposite side, right? Because it's opposite that angle, directly across from it. And that leaves us with one more. Well, 63 is directly next door to this line here, so that makes y our adjacent. Okay, so where can I fit that? That's the adjacent side over there. Okay, so we've got our opposite, adjacent, hypotenuse labeled. So here's how we work with any of these 90-degree trig problems when we're given an angle, solving for a missing side. Well, we were given the adjacent over there. We were asked to solve for the opposite. So we were not given, nor we asked to solve for the hypotenuse. So that's going to help me pick the right trig ratio. Now I've written them here. This is a shortcut. We go through the full explanation in class. Right here, I'm trying to find the triangle or the trig ratio shortcut up here that does not contain the hypotenuse. So if I look at the three triangles, well, the first one contains it right there, so that's not going to work. Second one contains it right there, so therefore this one we're going to be using the tan theta equals opposite over adjacent. Now, what makes these triangles nice to work with, these shortcuts, is that, okay, well, let's figure out what we're solving for. So we go back, it's the opposite that we're solving for. So when I try to, or if I want to solve for the opposite, that means it's going to be the tan of the angle multiplied by the adjacent, because they are side by side. If instead I was solving for the adjacent, for example, okay, just to show you how this works, if I was solving for the adjacent, it would be the opposite divided by the tangent, because as you can see within the triangle, opposite is over tangent, so it's indicating divide. But what we're doing here is we're solving for what is it again? The opposite. We're solving for the opposite, so it's going to be tangent times the adjacent. So let's do that. Opposite is equal to tan of whatever the angle is. That's the symbol theta if you've never seen it. And that gets multiplied by the adjacent. Okay, so I can start to fill this in now. Tan of the reference angle. So the reference angle was 63 degrees. That's the one that was given to us. We're multiplying that by, I believe, 4.2. Yes, it is 4.2. And let's make that calculation. One quick note, you can see we're working with tangent of 63 degrees. So make sure your calculator is in degree mode. You'll know if you get a different answer than I do. So tan of 63 is equal to 1.96, and a lot of other decimal places do not cut those off. Okay, I'm just going to do dot 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 indicating that I'm keeping them all. But make sure you don't round at this point. It's okay to round your final answer, but not during the process. Otherwise, you're going to get, a different answer than what you should. Okay, and these small details really do matter if you're in any kind of engineering type situation. And when I multiply 1.96 by 4.2, I get 8.2429, and a lot of decimals after that. So at this point, this is the final answer. I'm going to round it. I believe this assignment rounds them to one decimal place, so I will do that. And if it's 8.24, that should round to 8.2. All right, and what I will do now is go and check to see if the answer matches. And there it is, question number 2. The result is 8.2. All right, so we've done that correctly. Another note is I'm trying to show you along with the example over here, but please do not answer yours here on the first page. The way the assignment template is set up, the way I need you to follow it, is that all of your answers will go right here where there's space for them, right? I will also go through an example. So in the previous one, we were given one side, which happened to be the adjacent. We were given the reference angle, and we had to solve for the opposite. Okay, so we were solving for a missing or an unknown side given an angle and a side. Well, there's another type of example I want to cover to make sure you know how to do it. In this example, we are given two different sides, and we're asked to solve for an angle. And notice this is still a 90-degree triangle. All the ones we're working with are. So basically what I need to do here, my first job is to label this. So across from the 90-degree angle is always the hypotenuse. Right next door to the reference angle we were asked to solve for is always the adjacent, right? And opposite, so across from the reference angle, okay, it's always dependent on the reference angle, is the opposite side. All right, so we're given the adjacent, we're given the hypotenuse, we're not asked to solve for the opposite, nor are we given it. So we're looking for the triangle this time that does not contain the opposite. So if I come up here, that wasn't so good. If I come up here and take a look at which triangle I should be using. Okay, so I'm looking for the one without the opposite. So in this case, there it is. The opposite's in the first and the third, but it's not in the second. So cosine of the angle is equal to adjacent over the hypotenuse. All right, so come down here. We've got cosine of the angle is equal to the adjacent over the hypotenuse. Okay, we got that. So I'll fill in my values. 4.2 over 6.9. Now you can divide that out. You might get a long decimal, you might get a short one, depends on the values. I suggest actually keeping it as 4.2 over 6.9. Your calculator can handle that as long as you put it in a set of brackets. Now the next thing I need to talk about is that this is solving for the cosine of the angle, but we're actually interested in the angle itself, which means that we need to isolate the angle itself, and we've got this cosine function attached to it. So this is again a shortcut. We talk about we talk about some methods and details about this in class. But if we were to solve for it and isolate the angle, we need to take the inverse of the cosine function. Okay, so what's going to happen on the next line as we're solving this is we've now isolated the angle because cosine inverse is cos minus 1, should be shift or second function on your calculator, and what I'm going to operate the inverse cosine on is 4.2 over 6.9 as we have above, and notice I put it in brackets. This will ensure that your calculator actually uses the inverse cosine function on the result of the fraction. All right, so just to finish this off, now I'm going to do on my calculator shift cosine gives me cos inverse, cos to the power minus 1, and then, or at least that's how it appears, and then I put in 4.2, use the fraction button, 6.9, close my bracket. Okay, so one way or another you'll make the calculation, and I think that on your assignment final answers for degrees are measured to the nearest angle, so 53 degrees is what I will round mine to. So I made up a question here just to help you with the process. This is how you solve for an angle given two sides in a 90-degree triangle.